We had the pleasure to sit down with Nish and Tab to talk about Intel's latest processor, the Intel G3 series, which was designed for handheld. We do a deep dive on the technical side to understand its configuration and performance. My name is Alejandro Hoyos, and this is Talking Tech. Hey Nish, how's it going?
Good.
Thanks for being here with us. Appreciate you sparing a little bit of time on this very Computex busy week, but thank you so much. For those who are just meeting you for the first time, what do you do at Intel?
My name is Nish Neelalojanan. I manage the product management organization. We take care of all the client products which we put out.
Nice. So we just launched a new processor, the Intel Arc G series, which actually you're wearing that shirt right now, which is really nice. Can you tell us a little bit more about it?
Sure. So we've been experimenting with handheld gaming since our Series 1 Core Ultra products, Meteor Lake. We've been iterating, learning, and as we got into Lunar Lake, we did a whole bunch of power management features which would help with handheld gaming. As we got to Panther Lake, because the architecture lent itself for low power gaming, we were able to go customize the existing 12xe die with Panther Lake to be able to deliver a custom part or a tailor-made part for handheld gaming itself. And given the low power gamingness, we thought it's a big GPU integrated graphics with a CPU. We also created a new set of brand, the Arc G series, which we shows our commitment to this segment where a graphics first SoC, which we are going to build as part of our roadmap.
Okay, that makes sense. So did you guys identify part of the market early on? Is like, why handheld all of a sudden?
We've been experimenting with this market, and as the architecture evolved, Panther Lake is great for low power gaming. So we have put our Ecos on a performance cluster. This means the Eco has access to a lot of resources on the CPU, like the L3 cache, which is very good for gaming. So we can drop a lot of the games on the Ecos in the performance cluster, which gives a lot more power back to the GPU. So you can now play AAA games on a handheld at low power, which is awesome for gamers out there. So why not? We wanted to do something for the gamers, and we wanted to show the commitment, and we also wanted to make sure the Arc goodness is leveraged from 12 watts all the way up to very high TDPs.
Okay, that makes a lot of sense. So you touched there on a couple of things. You're talking about power performance. So from a handheld perspective, what are the characteristics you're looking to deliver a good experience?
We need power efficient performance both on the CPU and GPU.
Right.
And be able to balance that power where it needs to, so that you can play AAA games even on a handheld form factor. So that's one big thing. The second thing is the software layer.
Right.
So we need to make sure that you have zero game support, you have all the software innovation to be able to load fast, and all the upscaling technology so that you can have the right frame rate. So all the right software feature set and the middleware feature set where it can intelligently put the right workloads on the right cores and also balance the power. So overall, your power efficient performance, software layer, and then on top of it, hardware innovation so that it feels lighter, it feels nice on your hand. So working with the ecosystem to make that happen and with our partners to make that happen. So it's all three of those, and a lot of our learnings, a lot of working with partners and ecosystems, and also working with our OS partners like Microsoft to be able to bring that software innovation, and then obviously having the right hardware or SoC like we talked about with Panther Lake. All three of that put together is what we believe helps build a good handheld.
Yeah, that makes a lot of sense because you're trying to balance power, battery, experience, and also performance. So it is pretty interesting. You mentioned that we were working with the OEMs. When we launched this product, you know who were working, like who were the first ones to come with us to market?
As always, we work with a lot of partners. What you will see is MSI, Claw, so latest generation, and they've been a pioneering partner with us, starting Meteor Lake with all of our experiments all the way down now with Panther Lake. You will also see Acer and 1X Player bringing some of the earlier handhelds to market. There will be a lot more other designs coming in the future, but you'll hear about them as we have them ready.
And you said Microsoft, so we're working very close with them to help on the experience side, right? Once you turn it on and you have that, I think they recently changed the name. Now it's like the Xbox or what is it?
Yeah, so Microsoft has been investing in bringing a lot of these games into handhelds and making that experience better. So they have something called Xbox Mode, which allows you to load into an environment which is purely focused on gaming. And so we've been working on optimizing that to run very well on Intel.
Oh, that's great. Nish, thank you so much. Appreciate it for having us here.
No problem.
Thank you. So it's great to see you, Tab.
It's great to see you
Love
too,
to see you
Alex.
again. It's been a minute.
Well, thanks for having me here. I appreciate that.
Yes. So I heard you're going to be on vacations pretty soon.
I am. I'm going to be going to Athens, and I'm looking very forward to it. But not until I've spent time here in Taipei, which I love, and especially since we're talking about a brand new thing.
Yes. We're very excited to hear about the new Intel Arc processor.
Yeah, it's the Intel Arc G3. And it's the first time we've done a purpose-built SoC for handheld gaming. And it's a super important investment for us.
So that's pretty neat. So tell us a little bit more about this whole kind of new market of gaming. Like it seems that it's starting to evolve.
Yeah, it is evolving. Well, first of all, you probably know that PC gaming is going like this. And by 2029, there'll be more than 1 billion PC gamers.
1 billion.
1 billion PC gamers up top. Yeah. And not only that, PC gamers are more and more often using multiple devices.
Yes.
So you'll be playing on your PC, and sometimes you'll be playing on a console. But now more and more people are playing on these handheld devices. And a matter of fact, 34% of gamers have more than one device that they game on.
Yeah, I completely agree. I actually have a handheld device. And for me, coming over here, the biggest question was, do I want to bring my gaming PC besides my work PC or a handheld?
And it's a hard choice because handhelds are starting to get really good.
Yes.
And so for me, this is our typical playbook where we started experimenting with Meteor Lake, and then we got a little bit more involved with Lunar Lake, and now with Panther Lake, we're making the leap and we're building a purpose-built SoC.
So it has been like this evolution, not only from the part of the graphics and the processor, but also from the ecosystem, right?
Yeah, for sure. I mean, building a handheld takes a lot of work.
Right.
There's ID that you have to do, just getting the clamshells right and the displays right. You need power efficiency, so you're building all the thermals and all the fans and stuff. But more than that, it's all about software integration.
Right.
Because on a Windows platform, that can get pretty complicated.
Yes.
But today, I think with Intel's help and our OEM partners' help, that software problem is getting much, much better.
No, that is great. And we also seen, we have interviewed you for many, many years now, and we're good friends. And we have seen this evolution of the graphics. So this plays a big role when it comes to handheld.
It does. I mean, if you think back in time, we started off with sort of our legacy graphics, which was doing primarily light graphics workloads for integrated SoCs. Then Arc showed up, and we did our first Arc Alchemist, and we did discrete parts, the A series, and we learned so much. As you know, it was a hard time. It was
hard. But we learned.
But after A, we did B, Battlemage. And we got much better with Battlemage. We fixed a lot of our driver issues. Our performance got way better. Our power efficiency dramatically improved. And Battlemage went into Lunar Lake, our first SoC. And the momentum is building. We did our Battlemage discrete part, and we continued to work on that IP. And today we have XE3 IP that is built into Panther Lake. So all of that learning and all of that software work is paying off big time. More power efficient, more compatibility, day zero drivers. It's all a learning journey that's brought us here. But it brings up a good point is we're talking about Arc G3.
Right.
It's not a Core G3.
Exactly. That was going to be my question.
Right?
Yeah.
So I think to me, this is all about, well, what do you mean when you say GPU? Because obviously every GPU is paired with CPUs because you need the CPU to do sort of the part of the rendering, and the GPU does sort of pixel processing. Well, for us, now with a G series SoC, an Arc G series SoC, it really is starting to look more like a GPU with cores attached. Right, so think of it like integration of that complex, and a different way to think about it. And I think at the end of the day, integration almost always wins. So that's why we're calling this an Intel Arc G. It's an integrated graphics subsystem with CPUs and GPUs. Oh,
that makes a lot of sense. And since it's a handheld, right, the major focus on it will be gaming for us.
Yeah, absolutely.
So this is a Panther Lake architecture, right? But what is the difference between the Panther Lake, the processor that we actually have, to the Arc?
That's an excellent question. The big things we've done is optimize for handheld. That means effectively we've reduced the number of P cores. It has 2 less P cores. It has 1 less display pipe, so it can handle fewer displays, because obviously it's got a contained environment. We don't need to do many displays. And the third thing, we've done a little bit less Thunderbolt. So by reducing that IP, we're actually able to lower the power envelope and fit the performance profile of these handhelds.
Okay, that makes sense, because one of the first questions that came to my mind, because as a desktop and regular gamer is like, why are you taking away the P cores?
Yeah. Well, it's all about balance, because you're trying to hit a lower power envelope, and you want to basically do technologies that allow you to leverage the P cores that you do have, and I'll talk a little bit about IBC version 3.5, but if we can leverage the P cores that we do have, then we can save power and energy by balancing a little bit better.
Right, so there's that balance from the point of view of the hardware.
Yep.
But there's also, you guys have done a lot of things when it comes to the software and the firmware.
Yeah, we've got 2 technologies that are pretty important. One's called endurance gaming, which is a technique that allows us to cap frame rates and then do pretty sophisticated power balancing between CPU and GPU to hit a target performance level. And that performance level can be picked by a user with a little UI. The other technology we have is this IBC technology.
Right.
And IBC is all about being more intelligent about how we balance CPU and GPU power and how we manage the clocks. So we launched that with Lunar Lake, and that in the Lunar Lake instance, we did more about smoothing the CPU, GPU power transfers that were happening. It was going a little too quick. And we also did a little bit more of prioritization for GPU frequency. So all of that gave us better frame rates and better smoothness for Lunar Lake.
So IBC is an Intel BIOS control, right?
Yep.
Okay.
Intelligent BIOS.
Intelligent BIOS
See,
control.
it's smart. It's smart.
Making things better and frames per second, also
Yep.
power. So
Yep,
it's
absolutely.
pretty great.
And then we improved that with Panther Lake. We did a version 3 of IBC for Panther Lake, and we added more intelligence in how we're manipulating that transfer power between the CPU and GPU. Now we've got version 3.5 that we're launching with the G3. And in 3.5, we're doing something called P-core parking.
Oh.
And P-core parking means that when we identify the most important threads of a game, typically the render thread, we're going to stick that on a P-core, and we're not going to allow it to migrate around different cores. And what that does is it gives you smoother, more power-efficient gaming.
And I guess the reason to trying to park the P core is like before we were chasing, like there was a lot of scheduling, being able to move it around to different cores.
Yeah, Windows does all the scheduling for you, and it tries to, take most efficient use of all the cores that are available. But sometimes it doesn't know that, hey, this is your render thread. This is a very important thread. I should put it on my most powerful core and keep it there. And Windows doesn't have that visibility today, but obviously that's something that we're working through to improve tomorrow.
Okay, that makes sense. And also with Panther Lake, the new scheduling, instead of focusing on the P cores at the beginning, we have shifted that over to the E cores.
Exactly. Using the E cores first also does the same thing. It allows you to keep the most important threads on the P cores, and that has the effect of kind of improving the overall render throughput.
Oh, that's impressive. So since this is XE3, we have the different technologies in there implemented. Can you just a little refresh course on those?
Well, for me, and I haven't mentioned it yet, but the most important technology is XeSS and XeSS MFG. And to really understand why it's so important for this device is you really got to think about power efficiency.
Right.
So normally, first of all, to back up, XeSS is an AI-based technology that allows us to upscale a frame, and XeSS MFG is an AI-based technology that not just upscales, but generates additional frames.
Right.
And some people love it, and some people hate it. But I'm telling you right now that MFG on a handheld device is absolutely critical. It changes the experience dramatically. And it's all because AI rendering of frames, AI generation of frames, is dramatically more power efficient than raster.
Right.
So raster, you start from nothing, you kind of build all your information and you generate one image. With AI, we actually have prior images and we have a lot of knowledge built into the AI network. So more power efficiently, we can generate those interstitial frames. And that's what allows these devices, these handheld devices, to have such beautiful, smooth animation.
Yeah, it is hard for a gamer, for me, to start changing that point of view, that frame of like, okay, now this is performance, but now the biggest thing, the biggest constraint of things you have to keep in mind is power.
Yeah.
And rendering consumes a lot of power, so that's when this whole new view comes in
It
handy.
does, and I like to separate raster performance, which is traditional, from generation, which is this smoothing effect, right?
Right.
And I think a lot of people get wrapped up on, generated frames are not real, and they're not. They're there to smooth out the experience, and they do a great job on handheld. I would never claim that the performance of this device is 250 frames per second,
Yes.
because it's not. It's more like 50 or 60 depending on what you're running, but we're adding all these other frames that make the experience buttery smooth.
All right, so let's talk performance when it comes to their processors.
Okay, perfect. So I'm going to move to slides because I don't want to lie. But to begin with, let's talk about how G3 series compares to Lunar Lake, which is our prior generation.
Makes sense.
We are 44% faster on average at 19 by 10. And that's at 35 watts, which is absolutely incredible, right? So great performance. You can look at how that looks normalized, and you can see it's across 1 million games, okay?
Right.
So gen on gen, about 44%, which is pretty good.
Yeah, it's pretty good. Yeah, it's,
Right?
I mean, double digits and all the way to 44.
That's pretty good, right? Okay, and now if you go down to 17 watts, which is a different sort of power budget, we started off at 35.
Right.
At 17 watts, we're about 24% faster, right? Because more balanced, a little bit lower gain, but still huge playable frame weights at 17 watts. When you compare us to AMD, that's where people really want to know. So compared to the ASUS ROG Xbox Ally X with AMD Z2 Extreme at 35 watts, we are about 42% faster.
That's pretty
That's
impressive.
pretty impressive,
Yeah.
right? So if you're playing a handheld, and all of that is without any MFG, it's out without frame gen, that's just looking at XeSS as an example.
Oh, that's even,
Yeah,
that is
that's
very
pretty
impressive.
good, right?
Yeah.
And when you consider turning on all of our different technologies, it gets even better. This is normalized, showing you 42% across 1 billion games versus AMD at 35 watts. And another way to think about that is, since we're such higher performance,
Right.
you can trade that performance off for power savings.
Oh, yeah.
So at the same performance, we're about half the power.
So that means you can play for longer.
You can play for a lot longer, right? So it's a very significant upgrade compared to our closest competition.
That means that I can play in the airplane.
You can play on the
way here.
whole way.
Wait.
The whole way.
That is
Yeah, but
amazing.
we're earbuds. Everybody doesn't want to hear your game. But yeah.
Yes, that is very great. That can get a little loud.
Yeah.
So it's pretty impressive. So there's a lot of technologies here that I've seen that are really great. So pretty excited about it.
Oh yeah.
Yeah, a little bit told me that you've been playing this new game on your handheld. You're pretty passionate about it.
Well, I've got press coming up here, right? And I've always been a fan of the Batman franchises. I played all of them, Arkham City, Arkham, everything. And there's a Lego game that just came out called Lego Rise of the Dark Knight. Is that right? What's the name of the Legacy of the Dark Knight, I think? And it's actually kind of an anthology of all of the Batman movies.
Yes.
And so there's like little vignettes, and you're in a different Batman movie. So I played through it to get to the part where I'm in Arkham City.
Oh, nice.
And now, it's just so great. You can fly around the city. You can use your grappling hook. And yeah, I played it for the flight over and like all the time I've been here.
So you were playing it on the handheld.
Yeah. About 90 hours in.
90 hours in.
Rough, so far.
so far.
Yeah.
So I don't think you really like the game.
It's good. It's a good game. I also read that I think that they just had their first public weekend. I got an early version. Their first public weekend, I thought they said something like 80 million the first weekend, which is really a substantial amount of revenue from that game.
No, that is pretty impressive.
Warner Brothers, yeah.
So there's one thing that I don't think that we kind of forgot to cover. Like, there's two types of this processor, right? So
There is.
Yeah.
There's the G3 Extreme, the Arc G3 Extreme, and just the Arc G3. Now, the G3 Extreme has a full component of Xe cores.
Right.
So I think that's 12 Xe cores.
Yeah.
And the G3 is same P-core, E-core, 10 Xe cores versus 12 Xe cores. So slightly lower performance numbers than what I'm showing here, but not dramatically so.
No, that's pretty good.
Yeah.
Well, Pat, thank you so much.
You're
Appreciate
welcome,
it.
Alex.
Thanks for
Great
having
to
us.
see you again.
Good to see you too.
Yeah.